Good evening, everyone. Welcome to the revision portal. And we are now left out one day with 3 days, which is on 26, 27, 28, and final day is 29. Okay, so yesterday I hope you would have watched the one of the strategic videos that I had put across. So if not, please look into it. So which tells you how much you need to focus on each of the units, and of which the most important according to me is data analysis, where you will be able to score more number of marks, and this will definitely be able to get you a better mark band. Okay, if you are aiming for a 7 and if you are aiming just to pass, okay, both the extremes we need to look into. So definitely this will help you out to cross the boundary. Okay, so I thought maybe why not I teach or I do something like a video analysis or video on data analysis briefly about what kind of questions has been asked so far and how do you answer it. Okay, out of which I have chosen only one sort of technique, which is your graphical analysis. I have not chosen everything. Okay, data analysis can be a lot of it, but major to it is a graph based question, and mostly I have seen graph based questions will always be very similar. Only thing is a little bit here and there the context would be different. Okay, so therefore I just focused on it. I have taken several problems from several past papers, and then I have shown like what are all the possible questions you get from that, and anything that you get beyond this will not be possible. And later on whatever you get over here, say for example data analysis, as you know, it is for 20 marks. I think the questions that I am going to show you here would max to max cover only 12 marks. It will not cover all 20 marks, which means what happens to the rest 8? The rest 8 is useful, or it has been shown only to show something like questions based on concept wise. Okay, if this value is equal to so much, what is the value of resistance? So something like this, or maybe equation wise. So you need to have some idea of the domain data, domain analysis. So if you know the domain properly, then you will be able to answer. But without a domain knowledge also, how do you answer? Okay, that is what the first part of it tells you, which most probably will help you out to score something like around 10 to 12 marks, not more than that. Okay, the rest of it, whatever you have learned, will be useful for you. Okay, now let us begin with this. First question. So there is a graph given over here, something written here, e to this turned at time t equal to 0, thermal physics problem, and as you see the graph goes like this over here. Okay, so usually whenever you have a graph based problem, they will ask you to write down the line of best fit. So when I say line of best fit, most of them make a mistake saying that it should be a straight line, and they will draw a line which starts from here and they will draw like this over here, or maybe they will start from here, they will draw like this over here, which is completely wrong. Okay, line of best fit does not refer to always a straight line. It can also be a curve. That's why while I teach, I always say that it could be a curve of best fit. So let me just erase this. Erase this here. Right. Let me draw the line of best fit. In this case, the line of best fit for me would be, I'll start this dot over here. See, this is nothing but your uncertainty or the error bar. I'll take all these dots and see to it that a line of best fit, okay, should pass through all the error bars. It need not even always pass through, okay, the central point over here. Here, luckily, you have all the error bars to be of equal width. Okay, but there is a possibility that some of them could be smaller, some of them could be larger, and so on. So therefore, what I need is that I should start from here and I should go like this, maybe draw a smooth curve so that, see, I made a mistake here. It should be like this. Okay, there should be a plateau region, there should be an increase region, and there should be a curved path. 3 regions I look into it. Okay, so it would be one of the questions over here. I have not put that question, only important questions I have asked. So this would be 1 mark over here. Then estimate the initial temperature. Now what most of them have done in my regular classes when I ask this question is that they extrapolate this one to 0 and they think it is 0. It is not 0. So what you need to do is, initial temperature is a time t equal to 0. You extrapolate this one backward, that is you take a scale and draw it backward like this. So it meets somewhere over here. When it meets here, what is the range here? This is 15, this is 20. Read the boxes correctly. This would be 17.5 degrees centigrade. Okay, so it should just be a tangent. You're just going to extrapolate it. You're not going to add any curve over here. Okay, so therefore it is 17.5 degrees centigrade. Suggest why the temperature approaches a plateau region. This region. Image is being blocking. Okay, approaches a constant value. approach is a constant. Why do you get this region? So this is a domain based question once again. Okay, what's happening? There is some heater. Okay, so when you, as you keep on heating this one, the heater is turned on at time t equals 0. Graph shows a variation of the block at time t. So this is what happens. Now, is the heat escaping? Is the heat remaining constant? Okay, this is what you need to look at. See, when temperature is remaining a constant, what will happen? So let us say, for example, I have a beaker. Understand it from common logical sense. Okay, I have some water over here. Okay, this water is kept at, let us say, 80 degrees centigrade. Okay, now 80 degrees centigrade. Now, when you say the temperature is remaining a constant, will the temperature remain a constant? Temperature will never remain a constant, because when it is open to a surrounding, then definitely the temperature keeps on decreasing. But if it is not open to surrounding, it is being closed, will the temperature remain a constant? Okay, it will not remain a constant. Still, it will start decreasing, but maybe the rate of decrease might be lesser. Okay, in the condition like this, if you plot a graph of a temperature versus time, then probably if this is open, this will decrease immediately like this. If it is closed, if I put a lid here and close, it might decrease like this over here. But on the other hand, if I close this, okay, and then I also start heating this, such that the rate at which it loses the heat is equal to the rate at which it gains the heat. Something like this when I do, then what will happen is the temperature will remain a constant, right? So maybe this could refer to something like this. I don't have the full question. So if you refer to the full question, you will be able to write the context. Okay. So look at the context and then you need to answer this. Okay. Then when the temperature has reached a constant value, the heater is turned off. Initially, it is not turned off. It will take some time and later on it's been turned off. Okay. Like, or maybe you can say the temperature is saturated. For example, you take water and you heat it here. The maximum temperature it can reach is only 100 degrees centigrade, right? And then water gets converted into steam. You can say even that is also possible, right? Depends upon the question. I cannot say anything here. Then the graph shows the variation of temperature theta. Okay, this is theta of the block with temperature. That's what I have shown over here. Shows the initial range of the rate of change of temperature of the block is approximately -4 Kelvin per minute. That's what you need to show. So he is asking you about the rate. What do you understand by rate? Any quantity, the moment I say rate, divide this by delta t, change in time. Okay, then what should be on the numerator? Rate is always a fraction. Okay, it's a fraction. So what should be a numerator? Numerator is what you say after this particular phrase. This particular phrase is very important. Rate of change. Rate of change means put delta t here. Change of the temperature, which means you put delta t over here. Okay, delta t over here. Now what you do? Delta t by delta t you need to find. What is delta t by delta t? If from the graph, delta t here is nothing but delta theta here, and this is your delta t over here, right? So therefore, delta theta is change in temperature, change in time. How do I find? Find the slope, right? Change in y-axis by change in x-axis. Whenever in a graphical question, if there is a fraction being asked, immediately think that, okay, he is asking you something about a graph. Always remember, in a graphical question, there can be 4 things that can be used to extract the information. I've been telling this in many of my questions whenever I relate graphical questions in my MCQ on structured paper. Okay, the first one, what is the first one? First one is slope. First one is slope. The second one is intercept. Intercept. Third one is pixel. Pixel. Last one is area. Okay, these are the 4 important things that we need to know. We can use it to extract max information from the graph. So towards it, now what we have done, we need to find out the slope. How do you find the slope? Now if you look at this area, if you look at this, see, has already asked you to get an answer equal to -4. Okay, so you need to find the slope. If you look at this area, if you find the slope in this region, this appears to be a little bit curved here, and then you see this appears to be almost a straight line here. Any graph that is given, as a thumb rule, okay, if you are a researcher, you might be knowing, as a thumb rule, 50% of the line should be used, okay, while you're taking a slope. So what you do is take up any 2 points. Let us say, for example, the graph is not so big, so I will not be able to locate exactly. So I will take 1 point here. I will take 1 more point over here. 1 more point over here. Okay. So now for these 2 points, I will draw a triangle. Now when I take 50%, when I say 50% of the graph, take that 50% only if the line is a straight line. Okay. If suppose if it is a curved path, do not use that approach. Okay. So for example, instead of giving like this, if they had given you a graph like this over here, okay, and they will ask you to show that the initial rate of change of temperature of the block is approximately -4 Kelvin per minute at a particular value, then what you do is you can either take up that value and draw a tangent here and then find the slope for this. Okay, The length of tangent could be anything. It could be this much long, it could be this much small. Whatever it is, you need to find out it, because the slope keeps on changing in case of a curve, but in case of a straight line, it almost remains a constant. But if you look at this region over here, it appears to be a little bit bent over here. You might get a different value, so be careful. So therefore, take up the larger region. Okay, usually 50% of the region, and hence, okay, you will get a proper slope. I'm not calculating the slope, I'm just showing you the technique over here. Okay, let us move on to the next one. So definitely, let me tell you the marks, how much each one of them will carry. Just a moment, I already written all this. So it tells you something like, first question will carry 1 mark. So if suppose if this was there, this is 1 mark, this is 1 mark, this is 2 mark, and this is another 2 marks. So 2 plus 2, 4 plus 1, 5 plus 1, 6 over here. So 6 marks easily you get from the first question. Usually in a data analysis question, there will be 2 questions. So therefore 6 you have got here. Okay, next question. So this is a question on radioactivity. Suggest why the activity approaches a non-zero constant value. Suggest why the activity. This is a plot of activity in becquerels versus time in seconds. Any graphical questions, see to it that you understand what is the unit along the x and y axis. In a graphical question, see to it that you need to look at the unit, you need to look at what is each point at each box correspond to. So first thing that I do is the distance between these two will represent 5 becquerels over here. Okay. Suggest why the activity approaches a non-zero constant value. Non-zero constant value. Okay. Why does it approach? Again, there's a problem on domains. Okay. Radioactivity. So why does the activity of a sample initially decreases like this, and after that it keeps on remaining a constant? It doesn't become zero. It is not a constant once again. It doesn't approach zero, but it almost looks like a constant. That's the question. So how do you answer this? You can say that activity is nothing but, how do you write activity? Activity is nothing but dn divided by dt, right? And if I take n for example, you already learned calculus by this time. If I take n for example, I can write n naught e to the power of minus lambda t, which you already learned Excel based question. So therefore, dn by dt is nothing but, you're going to differentiate this, which should be equal to minus lambda n0 e to the power of minus lambda into t. And what I can do is I can now write n naught e power minus lambda t is equal to n. I can now write this minus lambda times n, right? I can now write this minus lambda times n. Okay, and thus I can now write a is equal to minus lambda times n. So as time progresses, what happens? The number of molecules also keeps on reducing at a lower rate. That means the activity also drops down at the same rate as that of the number of molecules, and as a result of it, okay, number of molecules is also seen to be fairly a constant, and hence you see that is also approached as a fairly a constant. It does not become a zero here, or this becomes zero. This can be one reason. This becomes zero. See, if you do not know the domain over here, you can say that this will become domain. This will become zero at t equal to infinity, right? If you keep on writing like this, how much, where can you extend? You can say 700, 800, 10,000, 20,000, 80,000, 1 million, and so on. You can say until infinity, right? So you can say this activity will become zero at infinity, and it takes a very longer time to reduce it to zero, right? You can mention it in general sense. Then estimate the half-life of proactinium-234. Okay, this is a problem of proactinium. This is the nucleus that you use. Half-life you need to find. Now what you do? Say for example, what is this value? This is 30, this 35. This could be, you can say 32.5. But can we have 32.5? You will not have 32.5. Use something like around 32 divided by 2. Okay. So therefore, let us say this is 32. So not 32.5. No, it is 32 over here. 32 over here. So how do you calculate half-life? When the activity reduces to half of this initial value, you get the half-life. Okay. You would have read this one in terms of number of molecules. Now you are saying something related to activity. But you see, how do you understand that? The activity is proportional to n over here. This is a constant. Don't worry about this minus over here. Okay, minus lambda is your constant. So therefore, activity is proportional to n. Whatever happens to n, the same thing happens to a also, activity also. Okay. So therefore, activity happens to n, activity is proportional to n. So if this is 32, now how do you define half-life? Half-life you define that if n becomes n naught divided by 2, the time taken for this to happen is nothing but your half-life. So therefore, now what you do is this 32, where is 16 here? 16 is somewhere over here. 16 is somewhere over here. So take up this 16 value here and drop a perpendicular here. Drop a perpendicular here. You might get something like around this 0, this 50, this 100, maybe around 80 to 90. Okay, state that as your activity. show the calculations on the graph so the examiner understands that you have done it. Okay. So therefore, this is somewhere around 80 over here. So what is your 80 over here? You should write the unit. Unit is nothing but 80 seconds over here. This is your half-life. If you want to confirm, okay, whether it is right or not, what you do is you have got this for 16 here. The next half-life could be for 8. Now what you do is go for 8 here. This is 10, this is 8, 8 is somewhere over here. You put the 8 over here and you get this line over here. So what is this now? This would be around 150. What is the difference between these two? This is around 70, this is around 80. So you cannot have a difference like this. Maybe you can say half-life ranges between 75 to 80 seconds. Okay, this is almost correct. Okay, you can write like this also. Right, next question. See, we already finished 2 questions, right? Now let me see how many marks we get over here for this. This question will carry 4 marks. This carries 4 marks. Okay, in 1 year's paper you already solved 6 and this is 4, so totally you are going to get 10 marks. So you had a limited amount of domain knowledge. You did not have much over here, but still you are able to do it. Somewhere some amount of reasoning is very much essential. If you know this, you can easily solve it. Let us move on to the next one. Just a minute. Okay. Right. So okay, now next one. Identify the evidence of a systematic error in the data. Now what is systematic error? For example, if I take this pen for example and I measure what is the length of this one. The length of this pen is seen to be, let us say, 15 centimeter, 20 centimeter. Okay. How do I measure? Maybe I take a scale and measure the length. Let me say the scale is incorrect in its readings. Okay. So what I do is I measure it this one here. So instead of the correct value being 20 centimeter, it is measuring something like 22 centimeter. Which means what? Maybe the readings or graduations are not proper. The markings are not proper. You get 22 centimeter. It's a systematic error. There's an error in this. Now, how do you call this a systematic error? Now, systematic error happens. Now, let us say, for example, after measuring this one, I take up something like this. I take up my spectacles over here and I measure this length over here. Okay, by a straight line. There also, instead of, let us say, this will not be 20, this could be around 24 centimeter. 24 is now, let us 26, which means what is the error here? Again, 2 centimeter. So, whatever I measure, anything is measuring 2 centimeter, this is an error. So that is what you got systematic error. In every trial, every observation, any object I take, it's always showing me the same amount of error, systematic error. Now, how do I understand systematic error? Now, what you do is, let us look at this. There's some graph given over here. This is m is equal to mu f square by g into lambda square. M is the mass. M is the mass in grams over here. And lambda, I think it is some wavelength over here. Now, you ask a simple question. If I put anything 0 here, what will happen to m? If I put lambda equal to 0, m equal to 0, that should happen, right? Okay, now, if I put 0, let us say, for example, if I extrapolate. Okay, first question as usual could be, draw the line of best fit. So, what I do? I can now draw the line of best fit. This is my line of best fit. First question, 1 mark. They have asked it, but I have not put it over here. Why repetition? Okay, and then the second question could be, draw the line of worst fit. Okay, which means take up this least point, take up this max point, and then draw a line which goes like this. It goes like this, and then take up this least maximum point in the lower bound. Okay, and then take up this lower bound over here, and then draw a line here. Draw a line over here. Okay, so this is your line of worst fit 1. This is your line of worst fit. Sorry, line of worst fit 2, and a line which passes through this valley, okay, is called as line of best fit. This is what we have. Okay, so they might ask you this one also, or they might ask you the question like draw the lines of maximum and minimum gradients. Which is a maximum gradient? This is your maximum gradient. LWF1 is your max gradient. This is your max gradient. This is your minimum gradient. Minimum gradient. This is your correct gradient. Gradient is slope. Okay, fine. Now, systematic error you need to identify. Okay, how do you identify? So, what you do is this correct line is there, no? So, what you do is you draw this line, extrapolate this line backward over here like this. Does it meet the origin? It doesn't meet the origin. So, which means it should meet the origin. If it is not meeting the origin, there is a systematic error. That's what you need to look into. Any kind of question when you have, okay, this could be your current versus voltage curve. It could be anything. If it does not meet the origin, there is a systematic error over there. Okay, identify the evidence for a systematic error. What is the evidence? It does not mean the origin, right? And what is it? What is the next part of it? And reason. You need to reason. What do you mean by reasoning? So if I put, so what is this around here? Lambda square. Okay, so it's related to something like frequency and lambda square of a string. Something related to, I think, stationary wave. Okay, when lambda equal to 0, that means there is no wave which has been existing. Then m equal to 0. Can this be possible? It's not possible, right? So this m could be something like the mass of the hanging weight or something. So definitely, so that's not possible. These are unrelated things. So therefore, there is a systematic error, right? See, m should be 0, but here what is the value of m you are getting? You are at m equal to 0. So at m equal to 0, you are getting a different value of lambda. This is not possible, right? So it should actually pass through the origin. It's not passing through the origin, so it's incorrect. So therefore, there is a systematic error. Now calculate the gradient of the graph. Gradient, what is the gradient? The slope. So find out the slope. As I told you, take 50% of the y and x axis, get the slope. You're doing this, okay? Now from the graph, we are moving to uncertainties. So these kinds of questions can also be asked. The percentage uncertainty of a gradient is 6%. Delta m by m multiplied by 100 is already given 6%. If I just take delta m by m, this will be 6 by 100, which is 0.06. The frequency f of the wave is given over here. So what is given here? This is your f0, and what is this here? This is again delta f by f multiplied by 100. Percentage is right. You need to look at that. Include the percentage uncertainty for mu in your answers and estimate using the answer to be for mu for the string. You need to calculate the mu for the string. Mu here. You need to calculate the value of mu and percentage uncertainty of mu. Now, how do you do it? Now, whenever you have an equation like this, okay, and he is asking you to find out the uncertainty for the mu, what you need to do is take the first mu as your subject, which means push everything to the right and take only mu to the left. So therefore, this should now be equal to mg divided by f square lambda square. I'm going to write like this only. Then use uncertainty propagation principle, which means what? You're going to find delta mu by mu is equal to, is the value of m changing? M is definitely changing because you had an uncertainty here. The bar was there, right? So delta m by m. What about the value of g? Is the value of g changing? Value of g is not changing. So therefore, this delta g by g was 0. Plus, what about delta f square? Let me write down that. So 2 times delta f by f. This is the mistake which many of you do. Since it is f square, you will put minus 2 delta times f by f, which is incorrect. Okay, errors will always be positive. It can never become negative. Very, very important to understand. So many of you, what you will do is you will directly take the propagation here. You will write delta m by m is equal to delta mu by mu plus 2 times delta f by f plus 2 times delta g by g. You do all this and you want delta mu by mu, you will send these to the other side and becomes negative, right? Which is incorrect. Okay, do not do by this approach. Okay, always do by this approach. Take mu first as your subject, whatever it comes. First take mu as a subject. Don't use the formula directly, and then you do this one here. So this will become 2 times delta lambda divided by lambda. Now substitute all the values. What is delta m by m? It was given some value, okay, which could be around 10 or 20. I do not know. It's not very clear for me. I cannot write that. And then 0 delta f by f. What is delta f by f? It's already given 2%. So write down this as 2 over here, and this as some, let us say 20 divided by m value. What is the value of m you will take? Okay, you take up any value of m, or it should be the same. Let us read the question. This is for 60 hertz, right? 60 hertz. So for 60 hertz, do we have 60 is not there. So using this, you need to find out the value of m. Okay, so now m is equal to mu. What's the value of mu? Mu is unknown for you. How do you do this value? So this is 60 hertz, like frequency is known, and then lambda frequency and lambda both are given. Frequency f of the wave is given over here. I think in one of the problems the value of mu should also have been given over here. Lambda should be given. So corresponding to it, maybe what you can do is, for a frequency, you can write f lambda is equal to constant c. Delta f by f is equal to, since I need f here, so what I will do is f is equal to c by lambda, and then I write delta f by f is equal to delta lambda by lambda. Okay, don't use negative there, right? 4 back to this. Okay, so therefore delta lambda by lambda and this are same, so this becomes 4 times over here. And delta f by f is already given to you, which is 0.02. Substitute that value and finally get the value for delta mu by u. But that doesn't stop over here. So once you have got this, then what you need to do is find out the value of delta mu, which should be equal to mu times whatever value you get over here. So once you get that value, and then you are going to write mu is equal to mu naught plus or minus delta mu. Okay, this is how you are going to do. Definitely this will be around 4 marks, and thus this could be 2, this could be 1, and this could be a, okay, let me take 3. 2 plus 1, 3, 3 plus 3, 6. So this is the way how you will be using propagation of uncertainties. Okay, let us move on to the next one. The student initially hypothesizes that f max is proportional to delta p. Show that the hypothesis is not supported. Okay, whenever you have not supported, you need to prove not supported. Now, how do you prove that it is not supported? Simple. What you do is take 2 values. See, not using the graph. You are not going to use the graph out here. Take 2 values. Take these 2 values for example. What is the value here? You can take first and second also, but you can take these 2. The difference over here, delta f and delta p. Delta f and delta p, what is it? 158 minus 133. Take the difference over here. Delta f here is 158 minus 133 divided by, now delta p. Delta. First find the ratio. Don't worry about anything. It's 30 minus 1 is 10 over here. Okay. 133, right? 133. Let me use my calculator to get this value here. So you have 158 minus 133, 25 divided by 10. I get this was 2.5. I'll write 2.5. Now I'll take 2 more values. Somewhere here I'll take. Okay. Any point you take, doesn't matter. Or maybe you can take any other difference also. If I do this one here, 192 minus 206. 206 minus 192. 14. So here the difference is delta f is 14 divided by difference along the delta p is 10 over here. So you get the answer 1.4. Now what do you understand? Delta f by delta p is slope. Here also slope. The slope is not a constant. If the slope is not constant, delta f is not proportional to delta p. Right? That's what you need to do. Okay. Whenever there is something like this, immediately you say that this slope is not constant. But if the question was reversed, if they had asked you, show that the f max is proportional to delta p, what you need to do? Take 1 point here, take another point here. Maybe you can take 1 more point here also. Okay. What I have done, I have taken 3 different value over here. So, and you are getting 2.5 here. Let us say you are getting 2.4 here. I'm not getting 2.4, 5. And here you are getting 2.6 over here. Okay. And almost at every place, whatever, how much ever values if I take for example, between these two also, I am getting something like a 2.55 here. Then I can say 2.4, 2.4, 2.6 and so on. All these values are very closer to each other. Mostly it resembles a straight line. A delta f is proportional to delta p. Okay, you can prove it like that also. Okay, so remember the condition for proportionality. Whenever I say that it is being proportional, which means the slope is a constant. This is what you can say. Now there is one more condition. What you got as a, see, if it is inversely proportional. So this is directly proportional. I am showing that also directly proportional. If it is inversely proportional, what do you mean by that? How do you prove that? Inversely proportional means, okay, see what did I do here? I took the values of x, I took the value of y, and I determined the value of delta y by delta x. This is what I have done. Now whenever you say inversely proportional, don't take the slope. But instead what you do is, you take the value of y, you take the value of y, take the value of x, take the product of these two. Okay, and then you find out what is the value. If the value is a constant at every place, then you say it is inversely proportional. If it is not constant, then don't do it. Do not use delta y by delta x over there. Okay, your slope, some people think, okay, the slope should become negative. Okay, if it is decreasing, all this, that's all wrong. Okay, remember, if it is inversely proportional, product of x and y should be a constant. If it is constant, definitely proceed for it. Then, okay, so therefore you have proved this. So this would be around 2 marks over here. State the unit for k. State the unit for k. Now what is being given here? How do you find the unit for k? This is a different question here. From here, this has been taken. Okay, so now in this case, okay, there could be a question on draw a best fit line. Okay, so again you will draw a best fit line over here. When you draw a best fit line, there is a possibility that will not pass through all the points. Okay, and then do not draw something like this. This is incorrect. This is incorrect. This is incorrect. Okay, do not do this. So what you should do is, how should a best fit line? Best fit line should almost pass through all the points. This is what is the condition. So it should pass through almost all the points. So how should you write? I'll take this value here. I take value here. If I draw it like this, what will happen? It will pass through this point. Now, let me take this point. Let me take this point. In between them, I will get a worst fit line. Now I take this point and I take this point. And if I draw this, I'll get another worst fit line. Max gradient and minimum gradient. Now where should your best fit line go? Best fit line should pass through this point, this point, this point, this point, and it should pass through the value over here, right? So I will draw it through a valley so that it passes through this intersection also. Pass like this. Majority of the points it passes. Passes like this. So this will be your best fit line. Okay. Now next step. Say the value of unit of k. Now when you have drawn something, it seems to be linear over here. How is it linear? It is linear, and the equation could be something like f max cube into 10 power 5. Okay, don't write 10 power 5. Is proportional to delta p. So how do you write the value of k? Value of k, now this could be f max cube is equal to some k times delta p. You need to find out the value of k. K should be equal to f max cube divided by, not delta k, it's delta p. So what is the f max cube here? N cube, it's already given. N cube divided by, what's the value of p here? See, kilopascal is something like, it is given you the suffix over here, okay, the multiple over here. I don't need this kilo, you just use pascal over here, okay. So thus your unit of k should be Newton cube per unit pascal, okay. And then, okay, you might get a larger value, you might get a lesser value, that numerical value can be anything. And plot on the graph the delta p value of 40 kilopascals. Now plot on the graph the value of delta f. Okay, so for 40 kilopascals, what you do is drop a line here. Drop a line so it touches this point. And then what is the value here? Drop a perpendicular here. This will be around 50, 52, 54. This will be 54. The answer should be 54 into 10 to the power of 5 Newton cube. Okay, don't worry. This is I should cube this, square this. Don't do all these things. Okay, because it's already taken as n cube over here. Just take 54, right? Okay, so this could be 1 mark over here. This could be 1 mark. This is 2. This is 1, and this could be another 2 or maybe 1. So totally 4 or 5 marks. Easily you get those. So you need not know any domain-based questions over here. Let us move on to the next one. The percentage uncertainty in f max is plus or minus 5%. Error bars at f max. Delta p is equal to 10 kilopascals. Delta p to 80 kilopascals or no. So this answers are given. Calculate the absolute uncertainty f max cube for delta p equal to 30 kilopascals. 30. There is 20. This is 40. 30 should be here. Maybe he is asking you about this point. This point. Okay. State an appropriate number of significant figures for the answer. Student now proposes f cube equal to k delta p. I have already taken this. Explain why the new hypothesis is supported. Okay, let us answer this one here. This we have already answered now. Okay, let us look at this here. Calculate the absolute uncertainty for the f max cube. Now it's already given f max equal to so much. Now what you do is, whenever such kinds of questions are asked, just take y is equal to f max cube. F max cube. So delta y by y will give me delta of f max cube divided by f max cube. This is what you require actually here. Now, how do you determine from here? So if I take this equation over here, then what I can do is I can find delta y by y is equal to 3 times delta f max divided by f max. Now f max by f max is already given as 5%. So this should be 3 into 5, which should be equal to 15%. Okay. Do not look at the graph, just directly dip it from here. Okay. So you have got this value. Now, okay, this one, calculate the absolute uncertainty for f max cube for delta p equal to 30 kilopascals. 30 kilopascals. We already got here. There is nothing given over here, so you can just choose this one here. Right? Okay. Next. Let us move on to the next one. The theoretical prediction for the variation of pi minus p0 is given by the equation pi minus p0 equal to 4g by r. There should be a gamma here which is missing. Okay. The actual paper was also missing. Suggest why the data is consistent with the theoretical prediction. Why is it consistent? Now you see the lines passes through all the data points. You can mention that all the points it is passing through, and hence okay, this pi, see, this is r inverse, or r1 by r here is pi minus p0 here. If I see, whenever a graph is given and an equation is given, first try to put it in terms of y and x. What is y? Y is y axis here, so put this y here. Y is equal to 4g by r. See, 4g into gamma, 4g into gamma, you take it constant, and 1 by r is nothing but x. See, what is now seen here? Y is equal to some y is equal to m into x. Okay, now what is that? It says theoretical prediction is given by the equation something like this. Now actually this should be related to y equal to mx plus c. Okay, but it's getting something like y equal to mx. What is the reason? The reason is because now see, scaling is not done here. See, we have got the value to be at 10 over here. It's not 0 here, so you cannot predict anything there. But anyway, this equation refers to a straight line. So you can say that this equation, the plot that has been shown over here and the equation follows a straight line, and it has been observed. So therefore, it is a straight line equation, and hence the theoretical data and the graph are seen to be consistent. Then show that the value of gamma is about 0.03. How do you find the show value of gamma? So 4g gamma, what is 4g gamma here from the graph? It's a slope. How do you find the slope? Take up this point. Take up this point over here. Take up another point. Take up this point. Find out what is your delta y, what is your delta x. What is your delta y over here? This is your pi minus p0. What is your delta x over here? Delta x is nothing but 1 by r over here. Okay. Now when I do that, what do I get here? See, this is pi minus p0 and 1 by r over here. I get this answer equal to 4g into gamma you get. I don't get the value of gamma here. I only get 4g by gamma. So if I get the value of slope, I get this value. And then what do I need to do? I need to get the value of gamma, which is equal to this calculated slope divided by 4g value. The value of g would be given to you. Substitute it, you get the answer. You get it nearly equal to 0.03. If you do not get it, that means you are missing some values, some numbers over here, some powers over there. Look into the power and you get the correct answer. Okay, now the percentage uncertainty for gamma is 15%. State gamma with its absolute uncertainty. Okay, now what you need to do, you get some value of gamma here, and it says value of gamma is 15%. What you should do is 15% of this value, 15% of this gamma is equal to 0.15 times gamma. So you would have got some value. What is the value you get? 0.03. Okay, 0.03 multiplied by 15, which should now be 0.45, and one more 0.045. You get this answer over here. So you should write 0.03 plus or minus 0.045. This should be your answer. Okay, next. Now this is a graph once again. One more question. The plot of t versus v, t versus v square, t versus v square. I think this should be for simple pendulum, I think. Okay. Why is it unlikely the relationship between t and v is linear? Now I hope you should be able to answer this question by looking at this, after learning all this. You look at this graph here. See, it is going like this. Can I say, hey, it's going like this? No, it's wrong. Okay. So somewhere what you need to do is draw a line linear. There are two conditions for linear. Okay. The first condition, it should be a straight line passing through the origin. Now, does it pass through the origin, and should it be a straight line? Now, look at this. If I draw this one here, this is very clearly a curve. It's not a straight line. So, you can say not a straight line, doesn't pass through the origin. You can mention both of them. Then, determine the fractional uncertainty in V when t is equal to 2.115 seconds. 2.115. 2.11 is here, 2.12 here, 2.115 should be middle here. Which point is looking at this point over here? Okay, so what is that he has got? You have got the value of t here. Fractional uncertainty in V. So how do you find the fractional uncertainty in V? So what you do is take up this value. So there are 2 points given here. Okay, there are 2 points given over here. So for t, this is 1 point. For t equal to 2.15 seconds, this is 1 point here. This is 1 point here. This is 1 point over here. Okay, you get 2 error bars like this over here. So get this value, get this value over here. Okay, corresponding to it, determine the fractional uncertainty in V you want. Okay, sorry, need not do this one here. You can see there's already a horizontal bar here given here. Determine what is this value. This value. Okay, this value divided by 2. You should divide by 2. This will give you the uncertainty. Okay, so you will get the uncertainty for delta V. You'll get the uncertainty for delta V over here. This is going to confuse you. Okay, I'll not write delta V by 2. I'll say this value, whatever I get here. Let me call this as delta over here. This is what you're going to get now here. Now you need to find this delta divided by 2. This will give you delta V. Then what you need to do? You need to find fractional uncertainty. So towards it, for the value of 2.115, what is the corresponding value for V? So this point will now lead to something like 1.125, I think. 1.125. What is this value? This is your V value here. And what's the value of delta V? Delta V, let me calculate this for you. So this value is, it's not clear. So this is 1.125. Where are my spectacles? Look at it. This will be fine. Okay, this feature I was not aware. Okay, now if I look at this value, each box. So what is each box here? 0.75 to 0.1 over here. There are 5 small boxes, which means each small box is 0.05 here. 0.05, one box here and the other box over here. Right? One box here, other box over here. So 0.05 is your uncertainty. I need not do all this. Okay. 0.05 is your uncertainty. This value is equal to 0.05 and this value is 1.125 corresponding to this value of t, right, 0.05 over. Okay. Now when I do this, so calculate this value, this will be your delta V by V and put it for one significant figure. Then determine V and give an approximate unit for B. Now this is for this question. Now what the student has done is, since it is not linear, so he has plotted a graph of t versus what? V square. Okay, which you got as normalization. Okay, to make it a linearization. It's not normalization, it's linearization. So we have linearized it by taking this equation. I get this one. Determine the unit for B. See, what is this equation? See, V square is on x-axis. Whenever you have a confusion like this, okay, in a graphical question, put the corresponding values, which means what? V square is for x-axis. Put this x over here. This is B over here. And this is A over here. Okay, and this is your Y over here. So y equal to A plus Bx is similar to y is equal to C plus Mx or y equal to Mx plus C. Which means what is M here? M is the slope. So determine the slope from here, you get the value of B. Very easy. So you need to get the value of slope from here. Estimate the absolute uncertainty in A. Now absolute uncertainty. What is uncertainty in A? A is the intercept over here. You get the intercept over here. Okay. So now what you do is you find out what is the point here, what is the point here. Once again, you get some point here. What is the value here? This is around, now let us look at this 2.11 to 2.12. There are 5 boxes, which means each box would be 0.02. 0.02. We can calculate it. 2.12 minus 2.11 divided by 5. It will be 0.002. Oh, this is a mistake we make. Okay. So therefore, when you have this much, what is this value? This value is 2.10. I marked something. Wait, let me remove this ink mark so that I'll be able to write it clearly. Really. Okay. It's around 2.1 here, almost touching this point, and this is around 2.09. First box, second box, second and 0.5. Maybe you can take second box over here, just neglecting this error. This is 3 boxes away from here. So what is the value you got? 0.002, and maybe you can take this to be multiplied this by 3. Okay, so this distance is this much divided by 2. which is 0.003. So what I did, I'll just tell you what I have done here. Now what I did was, I determined this particular width. I got. This is your, let me call this as some YOV. I got this value. Then I divide this by 2. This will give me my delta I. That's what you need to do. Okay. So get that value, you will get the delta I over here. This is your absolute answer in the next. Now comes the major part, which most of you make a mistake, which is nothing but electricity based question. This you have to be really careful. I can't help until unless your domain is not correct. So this becomes very difficult. But anyway, try it out over yourself. Okay. As much as I put some clues, let us understand what is it. The gradient of the line of best fit is 6.3 ohms per meter. 6.3 ohms per meter. First here, when you write ohms per meter, write this as resistance per unit length. Estimate the resistivity of the material of the wire. Now what equation you have? You already have resistance is equal to rho L divided by A. This is what you have. Now when I take R by L, I push this L downwards, this becomes rho by A over here. Okay, somewhere the area should have been given to you in the question. I don't have the full question. So definitely, now R by L, how do I get this? R by L here? R by L, I can find out the slope here. So if I get the slope here, I'll get slope. Oh, slope is already given. Estimate the resistivity of the material of the wire. Okay, so you should be getting the value of A. You need not use the graph directly. You should get this value 6.3 multiplied by area. Maybe the radius of the wire should have been given. Substitute will get the answer. Okay, but if this is not given and only the graph is given, then what you need to do is find out the slope and get the answer. Explain by reference to the power dissipated in the wire, the advantage of the fixed resistor connected in series with the wire for the measurement of power dissipated in the wire. How do I find? There's a power dissipated wire. There's a current which passes like this. So you get the power dissipated in the wire to be equal to I squared multiplied by R. This is what is the power dissipated in the wire. The advantage of fixed resistor connected in series with the wire for the measurement of R. What is the advantage of connecting this fixed resistor? Now towards it, now this is the resistor that you are going to, oh sorry, this is not the resistor. So this is what you are going to talk about it. Okay, now if you increase this value, see, because when you say you are going to find out the power dissipated in this wire, okay, based on this R. Now what is the experiment? I don't have the experiment because I always assume something like the context is not known and still you are able to answer the question. Okay, how do you solve this? Towards it, if I increase something or decrease something, I should be able to understand the power here. Now how do I understand? If the value of R is increased, then what will happen? The current passing through it will decrease. When the current is decreased, then what will be the power dissipated here? The power dissipated will also be I squared into R, okay, which also decrease. Hey, this will be a confusion, right? Okay, this will also decrease. So therefore, now with reference to power dissipated in the wire, you need to comment on power dissipated in the wire. The advantage of fixed resistor. What is the advantage of the fixed resistor? Which means what? If I increase this resistance, the current will reduce, and as a result of it, the power consumption on this wire will also reduce. That's what I can write, right? In a wire for the measurement of power. By understanding what is the amount of the power dissipated over here, I can easily find out, okay, what is the power dissipation. I can find out the value of R over here. The advantage of fixed resistor contains the wire for the measurement of R. Okay, next. Experiment is repeated using a wire made out of the same material, okay, resistivity is not changing, but of a larger diameter, which means what? Area is now increasing, which means what? The thickness is increasing. Initially, the wire was thin and then you made this much more thicker like this. Okay. And then on the axis in part A, draw the graph for the second experiment. Now you should draw a graph for R by L for a different diameter. That's what is the question. Okay. Understand the question, so you will be able to answer it correctly. Now, what do we have here? R by L is equal to rho by A. R by L, which is nothing but slope, is equal to rho divided by A. When this thickness is increasing, what will happen to slope? Slope will reduce, right? Which means you should draw a straight line. Okay, assuming this works for every wire, you should draw a straight line with a lower slope. How do you write a lower slope? Like this, right? That's very simple. Okay, do not write like this, do not overlap onto it, do not write a curve. Okay, because you are assuming that the equation works for everything, and thus you are going to write like this. This is the answer for it. Probably this could be your 1 mark, this could be your 2 mark, and this will be 1 mark, 4 mark. Easily you can get from here. These are context independent questions. Okay, just by looking at the graphs and looking at the circuit and with a little amount of domain knowledge. Of course, here you need domain knowledge. I am sorry. So this question, without a domain knowledge, you will not be able to do it. Okay, Ohm's law and is very essential to work with this. Okay, next one, outline why it is unlikely that T and V are linear. Very simple question. The first question in this was draw a line of best fit. So what you do? Draw a line of best fit. Okay, it's a curve which should pass through all of them in a smooth curve. It is not smooth. Okay, draw it carefully, and then calculate the outline why it is unlikely a T and V are linear. Again, you will be able to answer this. Okay, why? Because it's not a straight line. Okay, and then it is seen to be when V is increasing, T is seen to be decreasing. Okay, so hence it is not seen to be a straight line, and thus you can, this one thing you can answer over here. Calculate the largest uncertainty in T for this data. Largest uncertainty. How do you find the largest uncertainty here? Now what is given here? T is given here. Uncertainty in T is everywhere same. See, this is given over here. See, this is given over here. This value is given here. This value is given here. Everywhere it has been given over here. Calculate the largest uncertainty. The uncertainty in T is seen to be fixed. Then let us take up this value. Now if I take up the value of delta T by T for this value, delta T by T, what will be the value of delta T by T here? Will be very high. No, it will be very low. Will be very low because the value of T is higher. If I take the delta T by, I think we should be calculating the largest fractional uncertainty. I made a mistake. I just typed in over here. Okay, so therefore, so if I take this value here, this value of T is lower here. Value of T is lower over here. So this delta T by T would also be lower over here. Will be higher. This will be higher. Okay, so as a result of it, you can determine from here. Then a student suggests T equal to A by V, find the units of A. Now here also line of best fit. You can exclude this point and draw a line of best fit like this. 1 or 2 points you can always exclude, nothing wrong, but it should be very closer to this in such a way that if there is a point above the line, there should be a point below the line also. When you do something like this, it's fine. Okay, and then okay, student suggests T equal to A by V, find the units of A. Now what you need to do is take A as your subject. So A is equal to TV. What is the unit of T? What is the unit of T? Unit of T is seconds. What is the unit of V? Unit of V, see, this was here, look at this here. This kilovolt. Kilo is your multiple. Okay, don't use that kilo here. Just use volt. Multiply the volt. The answer is units of A is nothing but second multiplied by volt or volt into second. Okay. So I think most of the questions I have taken something from 2019 to 2024. Whatever questions are there, I have not chosen November over here. I didn't find time to take up this. Okay, almost all the questions I have chosen over here in 1 hour, probably is 1 hour, yeah, nearly 1 hour. Okay, and I have seen to it that most of them are the completely context independent and what kind of questions can be asked. I hope this will be useful and helpful for you. Do share these questions for those who need, okay, so that they will also be able to clear the exam without any difficulty. So what you should expect here is that you should expect from your data analysis out of 20, whether you are an SL or a HL student, you should at least get 12. Okay, if it is less than 12, you are in a danger zone. Okay, so therefore, from whatever I have taught you here, you might be able to get only around 8 to 10 marks. Okay, these are the commonly based questions that you can ask. You can get over here. Okay, you cannot get beyond this over here. Okay, thank you everyone for being with me, and I'm happy to say that we already crossed 1,000 subscribers at this time. And keep in touch. You can also share these videos to your juniors so that they can also subscribe to my channel and be along with me and make this channel a completely free one. Thank you.